Hello, today I'm going to be showing you how to solve a problem using a flow network. But before we get into that, I would first like to define what a flow network is. A flow network, also known as a transportation network, is a directed graph made up of edges, capacities, and vertices, in which two of the edges are a source and a sink. A flow network is a way of representing traffic on a network of roads, fluids in a network of pipes, and electricity in a network of circuit components. So, knowing this, it is important to note that in a flow network, the edges represent the tracks of a flow, for example, pipes, roads, or paths. The vertices can also represent the destination of the flow, for example, cities. The weights of the edges represent flow capacities, and the edges always point away from the source and towards the sink. So everything that comes from the source, which is the starting point, has to end up at the sink, the ending point. So now, moving on to our problem, which says, a freight company that specializes in moving and forwarding packages of goods wants to transport packages of newspaper from Canberra to Melbourne using trucks that travel between various cities on a one-way road. However, each truck that is traveling between two cities can only carry certain amounts of packages each day because of its capacity. With the different capacities each truck has, find the maximum load that can travel from Canberra to Melbourne using the max flow min-cut theorem. So now, in order to solve this problem, we will first need to represent it as a flow network. And to do this, the first step is to draw the edges, which has already been done. Now I'm going to add in the vertices and the arrows. This vertex here is going to be called the source, and this vertex here is going to be called the sink. This is the start and this is the end. However, in this case, I'm going to name the source Canberra and the sink Melbourne. Because in the question it says, the company wants to transport packages of newspaper from Canberra to Melbourne. Now I am going to turn each vertex into a city. I'm going to have this vertex here be city A, this one city B, city C, city D, city E, and that's it. Now on each edge, I'm going to add on a weight. From Canberra to city A will be the weight of 8. From A to D, 4. From D to Melbourne, 10. From Melbourne to city E, 8. From city E to city B, 10. From B to city Canberra, 6. From B to C, 6 again. From C to A, 5 from C to D, 4 from C to Melbourne, 2, and from C to E, 3. Overall, by looking at the graph, you can see that each vertex represents different cities that the trucks will be going to. Each edge represents a truck route, so like a highway. The arrows show the direction the truck is traveling to, which is one direction towards Melbourne. And the weights represent the capacity that particular truck can take. So now, to solve the problem, we have to find the minimum cut in order to find the maximum load. And it looks like to me that the minimum cut is going to be from here. So from 8 to 6. I'll just make that more. So from 8 to 6, so you go 8 plus 6, which is 14. So the minimum cut is from here to here, which equals 14, which then determines the maximum load, which is 14. So the only reason why from 8 to 6 would be the minimum cut is because 14 adds up to the smallest number in the whole graph. If I had cut from 4 to 5 to 6 to 10, it would have given me a sum of 25. And if I cut from 10 to 2 to 8, that would have given me 20. So as you can see, from 8 to 6 is the smallest number, which is 14, which then adds up to the minimum cut.